during this presentation, we have to study the concept of non-uniqueness of electromagnetic potentials. You know that A and phi are electromagnetic potentials. A is a vector potential, whereas phi is a scalar potential. With the help of these two potentials, we can define electric and magnetic field vectors. You know the condition del B equal to 0, Maxwell's field equation. From this, the value of B equal to curl A, curl of vector potential. Div of curl of a vector equal to 0. Now we may define the electric field E equal to minus grade pi minus dou A by dou T. This is our electric field. Consider this is equation 1, this is equation 2. Let us introduce a vector potential E dash and is obtained by adding a quantity gradient of a scalar, grade lambda. A dash is a new vector potential and is obtained by adding gradient of a scalar function lambda with our actual vector potential A. From this we can write A equal to A dash minus grade lambda. Now substitute this value of A in equation 2. The value of E electric field equal to minus gradient of phi minus dou by dou T of the value of A is A dash minus grade lambda. Then this is equal to minus grade pi minus dou A dash by dou T minus and minus plus gradient of dou lambda by dou T. This is E. Now take the negative gradient as a common term. Pi minus dou lambda by dou T. Just these two terms are combined by taking minus gradient as a common term. Taking it outside, pi minus dou lambda by dou T. Then write down this term as such. A dash by dou T. Dou A dash by dou T. This is E. This is equation 3. See this equation 2. E equal to minus grade pi minus dou A by dou T. Here equation 3 represents E equal to minus gradient of pi minus dou lambda by dou T minus dou A dash by dou T. Therefore, we may say pi dash equal to pi minus dou lambda by dou T. This is our pi dash. From this we can write pi equal to pi dash plus dou lambda by dou t. This is our pi. Now we can write the value of electric field E equal to minus gradient of pi. Substitute this value of pi dash plus dou lambda by dou t, then minus dou by dou t of a dash minus grade lambda. If you simplify this, you can get minus grade pi dash, then take this term minus dou a dash by dou t. Just we have combined these two terms. Then minus grade dou lambda by dou t. Here minus into minus plus grade dou lambda by dou t. See here minus grade dou lambda by dou t plus grade dou lambda by dou t. These two terms are cancelled. Then finally we may get the value of E as minus grade pi dash minus dou a dash by dou t. This is our E. We have taken E equal to minus grade pi minus dou a by dou t. Finally, we arrived E equal to minus grade pi dash minus dou a dash by dou t. If A is replaced by a dash, there is no change in the electric field. The same electric field is obtained. In the same manner, we can take the condition B equal to curl A. Now replace A by means of A dash minus grade lambda del cross. The value of A is A dash minus grade lambda. Now simplify this. It is equal to del cross A dash minus del cross grade lambda. The value of curl of grade lambda equal to 0. See this quantity equal to 0. Curl of gradient of a scalar is always 0, so this is 0. Now we can get del cross A dash, which is our B. If you use A comma pi, you can get the values of E and B. If A comma pi is replaced by A dash comma pi dash, we can get the same values of E and B. There is no change in the values of electric and magnetic field across. Therefore, we may conclude that the potentials, electromagnetic potentials, define the field across uniquely, but they themselves do not unique. Now the potentials A and pi define E and B uniquely, but they themselves are not unique. Here the function lambda is called Gauge function, and the transformation A dash equal to A plus grade lambda, pi dash equal to pi minus dou lambda by dou t are called Gauge transformation. The invariance of fields under Gauge transformation is known as Gauge invariance. With the help of A and pi, we have defined the values of B and E. If A and pi are replaced by A dash and pi dash, there is no change in the values of B and E. Therefore, we may say that the potentials A and pi define the field vectors B and E uniquely, but they themselves are not unique, means A not equal to A dash, pi not equal to pi dash. This is called concept of gauge. The invariance of field vectors B and E under gauge transformation is known as gauge invariance.